So my name is Elena Volkova, and I will show you several improvements that we have implemented in Model Compiler and Model Compiler Server. So the first one is a support for C++ 11 features, and first that we have implemented is support for R-value reference. So the problem and the request from customers was to actually introduce support for this double ampersand operator that is now a part of C++, that is a part of C++ 11, and it is used to implement move constructors and move assignment constructors. So this is a simple model that shows you how it looks like. So for example, I have my class, and in my class I can define a move constructor which takes as a parameter this R-value reference to my class. So before, the problem was that we didn't support this kind of constructs, and in the generated code you got only 1 ampersand instead of 2, and whenever you will try to use this R-value reference, for example, in class attributes, in function parameters, or in type def, so this ampersand was lost and it was not supported. So now we have added a support for this kind of data types. So this is how this type is defined in properties, and now when you run code generation on this, you will get correct output in your C++. So I will show you how it looks like, and it will also be correctly compiled, so the code that you will get. What is it? Something strange. Okay, try once again. Yes, so now it's okay. I was actually playing with this, preparing for the demo, playing with build servers. So maybe I did something wrong in the settings. So now it's working fine. I will show you how it looks like in the generated code. So here we have a target project, and I was using it for my class. So I will open generated code for my class. Here is how it looks like. So this is this this parameter that I was showing, and now we are using correct notation with double ampersands. Also, I would like to mention that this is not the only improvement that we have implemented. Now we also try to handle native types that you are using in your definitions. We are try to handle them as is. So what does it mean? That if you, whatever you specify in your native type, for example, here, this is the native type. Whenever you write here, as soon as it is a correct, syntactically correct construct, it will be generated without any change to your code, to the generated code. So this allows us to support also other cases, other specific cases that, for example, a compiler supports, but our parser that we are using does not. For example, during this improvement, we have also fixed a different customer case related to this my function. So this my function, it is using here unsigned, so it can be visible here. So as return parameter, it is using unsigned int, and then this special std call. This is a special operator for Visual Studio Compiler, I think. And before, we were losing actually this std call during code generation. Because our parser, it just it didn't understand this std call, it just extracted unsigned int. But for the compiler, it is okay, and Visual Studio Compiler, it understands this std call. So now in this sprint, after the improvement that we have implemented, you actually will keep all of this in the code, in the generated code. So here you can see that we are generating it as is, and we are keeping this std call. And whenever different, you can use different extensions that your compiler supports, and as soon as they follow the general C++ syntax, it will be generated without any changes to the header and C++ files. Another example where you can see that this is working is using, for example, using these comments in the generation. When you define a type in a native type, you can actually also use comments, and now they also will be kept, and you will see them in the generated code. Here, I was defining a type def to this my class with R-value reference with this double ampersands, and here how it looks like in the generated code. So this is a type def. And first, you see that now we are generating correctly this double ampersand. And also you see that another benefit is that if you want to have any comment, it will also be kept. And you will see it in the generated code. So in the previous version, comments, they were not supported and they were lost. Of course, I wouldn't recommend to use too much comments in your native types, but for some special cases, you can do that, and it will be kept in the during code generation. Also, I would like to mention that if you do not define any, for example, here in my class, I was defining this move constructor. So if you do not define it explicitly in your class, here, for example, I have a default class and I don't define it explicitly, then the default implementations will be generated. And this is controlled by C++ properties. Here we have a button, a checkbox to generate move constructor, and a checkbox to generate move assignment operator. So, but I would like to mention that these two features, they were present before. So they are still supported, and they are working. But now you also have a possibility to redefine this default behavior and to define your own explicit implementations of move constructor and move assignment operator, and use these R-value references in parameters of your functions, explicit functions that you define. But if you don't want, the default behavior will look like this. So this is an example for default class, and this is how it looks like default implementations for move constructor and default implementation for move assignment operator. So this is it about R-value reference support. Do you have any questions?